Welcome back, everybody. We're going to continue our talk of sound and the frequency domain. And what I'm going to do this week is talk about the three important properties of sound and give a general overview of what they are. And then in the next three videos, what we'll do is go into more detail on each of them. So the three important properties of sound that are out there are amplitude, frequency, and timbre. It's pronounced timbre, not timbre. So let's talk about what these are and how they define sound. The first one is amplitude, and what this refers to is how loud a sound is. But this is a little bit misleading because when we talk about amplitude, technically, what amplitude is the height of the wave, which corresponds to how much displacement we're asking our speaker to do. So how far we're asking it to move in and out. Now, depending on how far our eardrums are from the speaker, that's how we perceive loudness. And the way that loudness is perceived is actually a little bit different than how it's represented. What I mean by that is doubling the height of a wave isn't going to necessarily double how loud we perceive that wave as. And that's why we measure amplitude when we're talking about corresponding to our own perception of sound in what's called dB, or decibels. Now, there are a couple different types of decibels out there, such as dBFS, dB full scale, and dB SPL, or sound pressure level. And once again, we're going to get more into detail on that later. And understanding that distinction is really important for producers. But for now, just understand that our perception of amplitude or loudness isn't linearly related to the actual amplitude that we look at when we look at a wave. The next property of sound that's out there is what's called the pitch or frequency of sound. And this just basically refers to how high or low a sound is. So a high frequency sound or a high pitch sound corresponds to a short wavelength, whereas a low frequency or a low pitch sound corresponds to a very long wavelength. And generally we measure frequency in hertz. And sometimes we also can measure pitch, not just in hertz, but in terms of note names, which makes a little bit more sense. So that's where you would hear something like A4 or A440, which is A4 or A at 440 hertz. So there's a kind of relationship. And the reason we have the musical scale or the pitch and the frequency, which is actually the one measured in hertz, is because like amplitude, our brains don't perceive sound or the frequency of sound in a linear way. We actually perceive it logarithmically. So we'll get more into detail on that later, but the frequency of sound, of course, is another important property of sound. And the last property of sound out there is the timbre or tone color. And this actually refers to the harmonic structure of sound. And what we'll be doing is talking about how the actual shape of the waveform affects the frequency content. Now, we don't actually interpret these harmonics or this tone color as being different notes. We actually kind of see it as being the same note with a different color. And that's why, for instance, a violin can play a note at a given frequency, and a saxophone can play the same note at a given frequency, and a piano can play the same note at a given frequency, and maybe they're all the same amplitude, maybe they're all the same note or the same frequency technically, but the harmonic content or the tone color of those sounds are all different. One thing I do want to talk about phase, and it's not really a property of sound, and I know I made another video on this, so I don't want to harp on this too much, but once again, phase isn't a property of sound itself. It's a property that's kind of a meta property in the sense that it's a property that describes the relationship between two different sounds. And we also can't hear phase, so that's another good reason why it's not a property of sound. One thing I will mention is thinking about phase tends to be more important when you talk about low frequency sound. So these can include bass or sub-bass frequency ranges. And the reason for this is when you're in a room with a low frequency sound, the wavelength can actually become larger than the room itself. And you actually have to think about the fact that when these waves cancel out, you can create these areas in a room where you have dead zones, where the bass is canceling out with itself because it's hitting a wall, other kind of tricky things like that. If you have phase cancellation, it can actually happen for a longer time when two low frequency waves are slightly out of phase with each other, whereas with high frequency waves, they'll kind of be phasing in and out, but they're repeating so much more often that it doesn't matter as much. I'm really kind of playing fast and loose here, but just understand that this idea of phase cancellation and not wanting things to muddy up your low end because the wavelengths are so big is going to come back, and it's going to be really important when we start talking about mixing and talking about, when you're performing in a venue and things like that, what does this bass actually look like? Thanks for watching. In the next video, what we're going to do is go into more detail on that first property of sound, which is amplitude. So don't forget to subscribe and check out that Discord if you guys have any questions on any of this stuff we're talking about with sound. This is really exciting, and hopefully you're getting a better understanding of how sound works. See you in the next video.